Okay, here's our problem. A 50-gram superball traveling at 25 meters per second bounces off a brick wall and rebounds at 22 meters per second. A high-speed camera records this event. If the ball is in contact with the wall for 3.5 milliseconds, what is the magnitude of the average acceleration of the ball during this time interval? Okay, now I really want you to solve this problem using the given, find, solve format, so I will do that. So let's write down what's given, and I want you to write down what's given with a picture. Okay, so let's draw a picture of this. Here's my brick wall, and when we draw a solid surface, we kind of make a little hash mark like that to indicate this is a solid surface that's not going to move. And here comes my superball. Okay, and here it comes. Look at that. Look at all that speed it's got. That's what the streaking is all about. And it has a mass that's equal to, now it says 50 grams, okay? But in physics, we use kilograms. We don't use grams. So I'm just going to say it is 3.050 kilograms. Now, it turns out in this problem that that's not important. We don't need the mass to solve the problem, but later on when we're dealing with force and so on, it will be important. But here we have its initial velocity is 25 meters per second. And the way we say its initial velocity, the velocity it was traveling before it hit the wall, I'm going to call that V naught, equals 25 meters per second. Now it's going to hit this wall and bounce off. Now I don't want to draw over my drawing, so I'm going to redraw it after the bounce below the down here. So here we have, here's the superball, and it's bounced off the wall, and its final velocity, which I'm just going to write as v, is equal to 22 meters per second. That's what's given up here. All right, but here's an issue. In my coordinate system, in how I've decided to assign direction to everything, this velocity right here is to the right, and to the right is a positive direction. So this is positive 25 meters per second. But when it bounces off the wall, it's going to bounce off the wall in the opposite direction. And that's how I indicate opposite direction. It's going to go the other way. Here we're going positive 25 meters per second. That's to the right, but it bounces off at negative 22 meters per second. And that means to the left. So I'm going to give it a negative value here. Okay? And now here's, let's show the ball right here. This is while it's in contact with the wall. And it says that it's in contact with the wall for 3.5 milliseconds. So I'm just going to say that delta t is equal to 3.5, and I'll add a 0 here, right? 0 milliseconds. What does milli mean? Milli means 1,000th of a second. Okay? And the way I'm going to write it here, and what's given is times 10 to the negative 3. Whenever you see a millisecond, anything, a milli means 10 to the negative 3. Okay? Seconds. Okay, so I've drawn a picture of the problem, and now here's everything that's given in the problem. Now, what do we want to find? Given, find, and solve. That's the key to good physics problem solving. Okay, we want to find the average acceleration of the ball. Average acceleration. So we'll call that a bar, the average acceleration. So let's solve. Now, what is the operational definition of average acceleration? In other words, what do I do to calculate average acceleration? Well, average acceleration, by definition, is equal to the change in velocity over the change in time. This tells me what to do. Determine what the change in velocity is, divide it by what the time interval was, and you'll get the average acceleration. Okay, well, let's do it. Well, what does delta mean? It means final minus initial. Well, V final is negative 22 meters per second minus my initial velocity, right? Delta means, well, delta V by definition is V final minus V initial, right? Well, what is the final velocity? Well, we said that was negative 22 meters per second. What's the initial velocity? That is 25 meters per second divided by the time interval. The time interval was 3.5 times 10 to the negative 3 seconds. That is, this is how much time the ball was interacting with the wall. So, this, I'll get up my handy-dandy calculator here, and let's do it. 22. And then from that 22 meters per second, I'm going to subtract from it 25. And notice that I get negative 47 here. Negative 47. The acceleration is going to be in the negative direction. What does that mean? Well, we'll talk about that here in a second. But we're going to divide by 3.5 times 10 to the 3, and then divide. This is going to be negative 1.34 times 10 to the negative 4 meters per second every second. In other words, we're changing. This is a very high acceleration, right? Oh, wait, not negative 4. I'm sorry, this is positive 4. I'll just, well, let me erase that. It's negative 1.34. I got carried away by this negative here. Negative 1.34 times 10 to the 4 power. Now, what does that mean? That means this is a really, really fast acceleration. Look, it should be a very high acceleration. We changed our velocity a lot in very little time. That means the rate at which velocity changed was huge. So this is a huge acceleration. 13,400 meters per second every second. We can write that as. Now, one thing before we write the final answer. Notice that in the problem it wants the magnitude of the acceleration. What does magnitude mean? It means just how much did we have. It doesn't care about direction. And so I'm going to write magnitude by putting little absolute value around the variable for the average acceleration. And that just means, hey, I'm just talking about the magnitude of it, how much it was. I don't really care about direction. We're going to talk about vectors in Chapter 3. Vectors are quantities that have magnitude and direction. Obviously, this has a direction to the left, but we'll talk about that later. So the magnitude is 1.34 times 10 to the 4 meters per second squared, right? Because look, what is this, right? Meters per second times 1 over second. That's meters times 1 is meters. Seconds times seconds is seconds squared. So this is a shortcut way of writing the units for acceleration. And so here is my answer. So what's the big picture of this problem? The big picture is, what does average acceleration mean? It means the total change in our velocity from our final our final velocity minus our initial velocity divided by the time that change took, and then we just crank through that operational definition to get our quantitative answer. So there you go. There's the problem.